conceptual information on complex ions and coordination compounds and their uses, applications. So we talked about how these, in the previous video, how those polydentate complex ions can serve as really nice food preservatives. Well, here's another example of not in so much complex ions, but in coordination compounds. And so by coordination compounds, we mean, in this case, neutral compounds. Ethan, you're in the video now. Neutral compounds that are formed from Lewis acid, Lewis base chemistry. Okay. So for example, you can see here these two molecules I'm pointing out. These are the common names, cisplatin or transplatin. So we know that we could go through the naming system and get the actual name. So we'll say these are the common names, kind of like how water is the common name for dihydrogen monoxide. So, and these compounds are made from essential metal with Lewis base ligands, but because they are neutral, these two compounds are not charged. Instead of calling them complex ions, we call them coordination compounds. And we also notice here with this naming system, one version of this is called cisplatin, and the other version of this is called transplatin. And that has to do with their isomerization. So if you notice here with cisplatin, it has two chloride ligands that are on the same side and two ammonia or two amine ligands that are also on the same side. And then now if we switch the position of one of those, so these are in fact different molecules. They're not mirror images of each other, right? We actually break one of these chloride bonds and replace it with an amine bond and then switch that back with another chloride bond. So now you can see the chlorides are on opposite sides and the amines are on opposite sides. And that's why we call this transplatin, okay? And so as it turns out, these are really, really useful, okay? But only one version is useful. So transplatin is basically worthless, okay? And I'm sure there's some pharmaceutical biochemists out there that are going to be like, what? No, that's not true. Cisplatin, as well as carboplatin, which you can tell here is very similar to the cisplatin, but instead of these chlorines, it's got this big organic structure, but it does have the two amines on both sides. This is a chemotherapy drug, which is just fascinating, right? That we switch the positions of atoms and it renders it either completely worthless or as a chemotherapy drug. And so this is really cool the way this works as a chemotherapy drug. For one, without getting into a long, complicated explanation, this particular molecule, and more so carboplatin is a more modern version of cisplatin. These are designed to get in there and find quickly replicating cells. And those quickly replicating cells can be hair, fingernails, or cancer cells. Okay, so without kind of getting into too much of this, and you can see those chlorine groups, one ends up becoming a water and leaves one chlorine behind. And when that happens, this can actually attach to the base pair of DNA. So if you zoom in here, it's really difficult to see this, but in this DNA strand, there are free amine groups. So I'll just represent that by saying something like this, right? So within this DNA structure, there are free nitrogen ligands, free nitrogen Lewis bases, okay? And because this platinum is really good at bonding to the ammonia, as it turns out, the ammonia or the amine is a better ligand than chloride, and we're not going to get into those details why. But as it turns out, because of this cis structure, both of these chlorines preferentially leave the platinum, and the platinum now gets replaced by bonding it to two nitrogens. So now you can see what's going on there is it's bonded to two of these free nitrogens. And you notice how that DNA is starting to kink, right? So when this happens, eventually that DNA strand will snap. So here I'm showing you like once, it's bent out of shape like that, the complex ion can, or excuse me, the coordination compound can literally snap that DNA right in half. Okay, so which is a great thing if that's cancerous DNA, right? We want to cut that off, break it off, don't let it replicate. Okay, um, but this is also why these types of drugs can induce hair loss, fingernail loss. They can wreak havoc on your immune system. Anything in your body that's quickly replicating, this molecule will target. So, another way to think of these chemotherapy drugs is that they are, in fact, poison. When someone takes a chemotherapy drug, they are actually poisoning themselves, just not to the point where they would actually die. Um, but if any of you have had family members that have had to go through this, I'm very sorry about that, and you probably recognize that they were basically poisoned um, in order to fight the cancer. Okay, so this is definitely a huge active area of research and trying to improve those nasty side effects. Right, what we want is a drug that can target the cancerous DNA and nothing else.